Your plants are running on empty, not because you're not feeding them, because the electrical system isn't working. Through electron transport chains, molecular circuits, moving electrons through proteins, creating energy every cell needs. In chloroplasts during photosynthesis, plastocyanin carries these electrons. As one of the most abundant proteins in leaves, it's absolutely essential for converting light into chemical energy. Plastocyanin requires copper as its functional core. Without adequate copper, electron transfer slows. Photosynthesis drops to 60 to 70% capacity. Growth stagnates. This isn't about nitrogen or phosphorus. This is about whether your plants can generate power at all. Hidden copper deficiency affects gardens more than most realize, particularly high pH soils above 7.5, sandy soils where copper leaches, peat-based soils, and areas with excessive organic matter-binding copper. If you've optimized NPK but plants still underperform, copper deficiency might be the invisible limiting factor. Copper, the conductor your plants need to turn sunlight into growth. The electron transport problem. Here's what happens inside healthy leaves. Photons excite electrons that cascade through photosystems while plastocyanin shuttles them between stages. This copper-dependent protein maintains electron flow, driving ATP and NADPH production. Without adequate copper, plants are forced to substitute cytochrome C6, a much less efficient alternative. In fact, research measuring chlorophyll fluorescence shows copper-deficient plants have reduced electron transport even when chlorophyll appears normal. This is why copper deficiency doesn't look typical. Leaves might be green, but growth is stunted, tissue weak, vigor poor. The problem is invisible, the electrical system powering everything else. What static soil means. Copper availability depends on soil pH, organic matter, and total copper content. In alkaline soils, copper binds tightly and becomes unavailable to plants. In sandy soils, it leaches away with each rain. In weathered soils, it was depleted long ago through decades of intensive farming. The term static soil captures this perfectly: electrically static, unable to conduct the metabolic processes that generate plant energy. Plants run at reduced capacity like a house struggling with undersized electrical wiring. The power is there, but it can't flow properly beyond photosynthesis. Multiple copper-dependent enzymes are essential for plant function. Cytochrome C oxidase, the final enzyme in mitochondrial respiration. Without it, plants can't fully extract energy from the sugars photosynthesis produces. Superoxide dismutase neutralizes toxic oxygen species generated during metabolism. Deficient plants accumulate oxidative damage that leads to premature cell death. Polyphenol oxidase, essential for lignin synthesis, which provides structural rigidity. Weak, floppy growth often indicates copper-limited lignification, preventing proper cell wall formation. Ethylene receptors require copper for sensing environmental stress and regulating flowering, fruit ripening, and developmental transitions. Remove copper from any of these systems, and the entire biochemical machinery slows to a crawl. Why this gets overlooked? Agricultural extension services test for copper deficiency, but consumer garden marketing focuses overwhelmingly on NPK fertilizers and seasonal products requiring repeated purchases. Copper deficiency manifests as general poor growth and reduced vigor symptoms easily attributed to insufficient fertilizer rather than specific micronutrient limitation. Farmers growing cereals in copper-deficient soils see 20 to 50% yield losses from subtle photosynthetic reductions, not obvious symptoms. Copper sulfate costs $20 to $30 for substantial coverage, applied once, lasting years. No recurring revenue. Marketing budgets flow toward products customers buy seasonally. One-time corrections lasting years don't fit the business model driving consumer advertising. Diagnosing copper deficiency. Important: not all gardens need copper. Some soils, particularly vineyards, orchards, or gardens, using copper fungicides extensively may have excess causing toxicity. Testing is essential. Deficiency symptoms include stunted growth despite adequate water/NPK, twisted or malformed new leaves, dieback of growing tips, weak, floppy stems, chloroplasts, young leaves while older remain green, poor flowering or fruit set. Definitive test: soil analysis through agricultural extension offices, $15 to $30. Adequate copper: 0.05 to 0.5 ppm in soil, 3 to 10 ppm in tissue. High pH soils often show reduced availability even if total copper is present. If tests confirm deficiency, you've identified the limiting factor. If adequate or high, adding copper causes harm. The solution that generates power. Critical: application rates must be determined by soil test results. Copper dosing is not guesswork. For soil amendment, typical rates for severe deficiency are Tauto 6 pounds per acre, approximately 1 to 3 ounces per 1,000 square feet, incorporated into top, 6 inches. Rates vary by soil type, pH, and organic matter. Sandy soils need less. High pH soils require special consideration. Do not apply without soil tests showing deficiency. Get baseline copper levels through your agricultural extension office. Follow their specific recommendations. For foliar application, 0.5 to 1 tablespoon copper sulfate per gallon water, sprayed until runoff. Provides temporary relief while addressing soil deficiency long-term. Critical safety warning: copper is a heavy metal persisting indefinitely. It accumulates with every application. European vineyards using copper fungicides for decades now face toxicity requiring extensive remediation. Damaged soil biology, inhibited growth, contaminated ecosystems. Excessive copper permanently sterilizes soil, kills beneficial bacteria, destroys mycorrhizal fungi, damages earthworms, creates conditions where nothing grows properly for years. Testing is non-negotiable. Know your baseline. If copper is already adequate, additional applications cause catastrophic harm. Never exceed recommended rates. Never apply just in case. The range between correction and toxicity is extremely narrow. Results when deficiency is properly corrected within days to weeks. Accelerated growth, healthy new leaves, strengthened stems, improved flowering, increased disease, resistance, transformed vigor. This isn't fertilizer boosting growth, this is restoring electrical function. Like replacing corroded wiring, the power was always there. Now it flows properly. What unlimited power really means. Plants in copper-adequate soil run metabolic machinery at full capacity. Photosynthesis operates at maximum electron transport. Respiration extracts full energy. Antioxidant systems protect cells. Lignin synthesis creates strong tissues. Unlimited means unconstrained by micronutrient deficiency. The ceiling is removed. Instead of 60% capacity due to bottlenecked electron transport, plants access full genetic potential. This won't make plants grow without light or water, but it removes the invisible metabolic constraint limiting countless gardens. The economics. Soil testing, $15 to $30. Copper sulfate, if deficiency confirmed, $20 to $30 for 5 pounds. Proper application, treats substantial area, lasts years. Compared to synthetic fertilizers requiring repeated applications, growth boosters with proprietary blends, and products targeting symptoms without addressing causes. If hidden copper deficiency is the limiting factor, adding more NPK won't help. You're trying to increase power consumption when wiring can't handle current. Fix the electrical system through proper diagnosis and targeted correction first. Then everything else will finally work the way it should. The knowledge underground. Traditional farmers who maintained copper-adequate soil never experienced limitation. But some areas now face opposite, toxicity from decades of fungicide accumulation. Both extremes impair function. The knowledge that didn't transfer Test before treating. Agricultural science measured micronutrients and adjusted based on actual conditions. Consumer gardening assumed NPK would cover everything. Research validates what proper management showed. Copper is essential for plant power generation. But essential doesn't mean more is better. It means precise amounts matter. Test your soil through extension offices for $15.30s. If deficiency is documented, correct with precise applications. If adequate or high, investigate other factors. The difference between thriving and struggling might be hidden in your soil's electrical system, but the only way to know is through testing, not guessing. Unlimited power doesn't come from blind copper applications. It comes from understanding what your specific soil needs and providing exactly that, no more, no less. The process is simple. Test, diagnose, correct if needed, monitor results. That's how you turn static soil into power-generating earth.